Right. SD WAN, software defined wide area network. See, wide area network plus software defined. So if you will say, I have not done this, you're wrong. This is wide area network. You cannot ignore protocol like ISIS, MPLS, BGP, OSPF. When you say wide area network, you will always have only these protocols. Whether it is SD WAN or simply WAN, you must know MPLS, you must know OSPF, you must know ISIS, you must know Internet network, policy-based routing, everything. You are just adding one thin layer of software to it. If you have this type of perspective towards SD-WAN, then you have the right perspective. Other than this, there is nothing. Those who are not aware of MPLS, nor MPLS layer 3 VPN, nor segment routing, or MPLS traffic engineering, or segment routing with traffic, if they are unaware of these things, for them SD-WAN is something new. For them SD-WAN is replacing MPLS. These are all the stories that people will make. Oh, SD-WAN has come. Why still you are learning MPLS? Funny people. They really don't know what is SD-WAN. They are the one who will say, oh, SD-WAN has come. No need of MPLS. No need of all this routing protocol. I don't understand from where they will run that software if they don't want to use MPLS and BGP and ISS and OSPF, and if they don't want to have the traffic engineering, then I don't understand what that software is going to define. If you want WAN to be defined by software, the software need to first of all understand this MPLS, that segment routing concepts, traffic engineering concepts. So when that software understands that, then you can define that WAN using software. That is what SD-WAN is. For those who have done MPLS layer 3 VPN, traffic engineering with RSVP, segment routing with traffic engineering, we used to call it as loop-free alternate, topology loop-free alternate. So if someone knows all this thing, their angle of seeing the SD-WAN will be the right angle. Without knowing those things, when they come to SD-WAN, they think that SD-WAN is new. It is not new. You used to do this when you do traffic engineering with segment routing. We used to put a word called color. Here also you will have color. In segment routing also, if you want to define a path, in MPLS RSVP tunnel, we used to say path option. In segment routing, we use the word color. Here also you use the same word color. Here also what you do? Path option. So, without knowing all this, people talk a lot of things about MPLS. People try to understand MPLS without having this knowledge of segment routing, MPLS, VPN, layer 3, traffic engineering. That's the wrong approach. We have just added a controller and orchestrator, which you call it a software defined controller. Instead of we doing everything command line, now. So when we do this SD WAN course, if you will correlate with what you already know, then SD WAN will be an old story for us. Only the way that it is applied, configured, matter difference is the difference. But the protocols are same. The working principles are same. But the way that you push the configuration into the router is the only difference. Classically, we used to do the segment routing, traffic engineering, MPLS, all those VPN stuff, going to every single router. I need to go to site 20, site 30, 40, 50, site 1000, site 1. I need to go to every site, and on every edge router, I need to configure. If I want to do some sort of tunnel, like we did DMVPN. So where you did? We used to do on the edge routers, spokes edge router, hub edge router. So physically you have to go there, or you need to take a remote session and put some configuration in order to do VMVPN. But with SD-WAN, you don't need to go to anywhere. You need to stay in one place, put the configuration using a web GUI, and based on what you have configured for a 50 site and 40, site number 40 and 30 and 20, based on what you have configured on site 1, we manage site 1, you see on the right top, we manage. You go to the V manager and you say, site 50, this is what I want it to be. This is what the route policy need to be. So you put everything on V manage in site 1, and when you deploy, it gets deployed here in 50, 40, 30, 20, and 1000. So you got a single pane of glass for all the sites. I have taken two different domain. So for one, I've spoken about the service provider domain. I have also spoken about the security domain now. I took an example of DMVPN that you configure on the edge routers of every site. And I have also taken the example of how MPLS, layer 3 VPN traffic engineering works, segment routing, traffic engineering works, the path options. But those things we don't do on CE router. All those segment routing, all this traffic engineering, all those layer 3 MPLS, we do everything on the provider. But now, if I combine these two, what is that? DMVPN kind of secured tunnel using all those labels and segment IDs, colors to identify the path option to reach a destination. Not done on provider router, instead it is done on customer edge router. That is what segment routing is. So I'm trying to correlate and explain you the variations between the normal segment routing and MPLS layer 3 VPN, traffic engineering, or I don't want to say simply repeating again MPLS layer 3 VPN traffic. I'm going to simply say segment routing traffic engineering, or traffic engineering with segment routing from now on. Because both basically use labels only. Now, what I'm trying to say is the thing that we used to depend on the service provider, we who? the enterprises. Now you don't depend on the service provider. You can yourself have a tunnel, traffic engineering tunnel, between the edge devices of various sites, along with the IPsec encryption. So if you say, do we need a DMVPN if I have segment routing? Sorry, SD WAN? My answer will be depends. Maybe you'll prefer the segment routing. Sorry, why am I saying segment? SD WAN path. In case if SD WAN path fails, then you may use DMVPN. I want a secure tunnel. SD WAN provides IPsec secure tunnel, but as a backup, I also want to have DMVPN tunnel. In that case, I need both. But there may be some people saying, no, why do I need DMVPN when I already have SD WAN? Fine. In SD WAN itself, they have two path options. You see here in this picture, MPLS, Internet. So they may have a policy. Use MPLS. If MPLS is not available, then you can use Internet to reach the sites. Or for so and so VLANs, use MPLS. For so and so VLAN, use Internet. These are all policies. So what I am trying to say here is all those that we have learned so far still exist. That MPLS that you learned, the segment routing that you learned, still exist in the cloud. They are not going to throw those things. In order to provide you fast routing, they have to continue using labels, segment, SIG-IDs, etc. So on the service provider side, they're not going to do any changes. Our SD-WAN configuration on the enterprise edge is not going to make service provider throw those BGP, MPLS, and segment routing. They're still going to have it. Now, from your side, from the customer side, you got an additional privilege of forming your own tunnel. Earlier, for VPNs, we used to depend on service provider. And service provider used to charge for that. But now you can have your own VPN. But again, I want to tell you, the VPNs that the service provider earlier giving to you still exist. So when service provider provided you a VPN earlier, when they provided you a VPN, the VPN was between this end to this end. That is still needed for your packet for having better quality communication. Now you're going to have, by using this VPN, you're going to have your own VPN from end to end. So for your VPN, this VPN service is really needed. So what I'm trying to say is, because we have moved to SD-WAN, service providers are not going to drop that MPLS tunnels. They have already given you a VRF. Your traffics are entering into service provider through a VRF. So they're still going to provide you the VPN service. Now, that VPN service was not between CE to CE. Now it is going to be CE to CE when you have SD-WAN. So you may have a question arise in your mind. So are we going to have VPN inside another VPN? Yes. Service provider VPN is already there. And your VPN traffic between the edge go through that VPN provided by the service provider. So in that way, it is VPN inside VPN. So this clarity is needed. This clarity is needed. Just like that, people command saying SD WAN, all MPLS is gone. No, you still have all those things. I can say SD WAN is an advancement to the segment routing. Traffic engineering using segment routing was reconfiguring manually on command line all those path options called colors. Here we automate it. But behind the screen, some IDs are going to be used. We used to call it as SIG ID or MPLS labels. In segment in SD-WAN, they're going to have another name. That's all. There is going to be a tag. And what is that tag? In ACI, correct. In ACI, we call it as VXLAN ID or VNI ID. In ACI, we call it as VNIs or VXLAN ID. Something similar to that we also have here. Only the name differs. The concept remains the same. Fine. To do this, what is needed? See, to do segment routing or MPLS layer, MPLS VPNs or segment traffic engineering using segment routing and MPLS, you don't need any special device to buy. With your existing ASR router or XC routers, you can do it. What is the benefit for Cisco in that? Nothing. You already purchased that. You have already purchased that device, and now you are going to upgrade the operating system, and you got the new feature called segment routing. What is the benefit for Cisco? What is the business benefit? Nothing. So they decided to come with a business idea, business technique. They said, okay, let us put one software to do this. And let's have a controller to do this. And we'll make the people pay for the controller. And the other guy said, hey, no. Just controller. No. We should not give that easy. We need to make more money with that. Okay, fine. Tell me an idea. Give me an idea. That controller will only work if they buy a special edge device. And to talk to the special edge device, they need special smart device, special manager, special authenticating bonding device, and they are going to pay for each of this for the license and etc. And Cisco said, well then, my boy, you are the only employee that who can make our company leave. Great. So let us not promote any more MPLS, layer 3 VPN or segment routing. Don't talk about those topics anyway hereafter. Let us focus on making money. SD WAN controller. So engineers no need to worry about anything called segment routing. No need to think about that. You just buy this controller. Controller will do everything for you. Don't ask me how it do. It does for you. That's all. You need to simply buy the controller. You need to go and put the inputs. It will do it for you. Don't ask more question. That is what SD WAN is. Don't ask more question. It is now black box. We don't know what is inside, how it works. Nothing. When you learn segment as SD WAN without segment routing, it'll be like one black box. All those who say they know SD WAN, what they mean is actually they mean the GUI, the web GUI. They know how to use the web GUI. That is what they claim to say that they know SD WAN. But truth is, they really don't know the working principle behind SD WAN. So when they learn through definitions. They learn through PowerPoint presentation. Color is a policy of path selection. What color? It's nothing but path option. Because we come from a proper background, traffic engineering background, we know what color means. For others, it's simply color. Color means a marking. Okay, so there is a dependency here. In SD-WAN, you don't need you don't have any dependency. Sorry. In segment routing. In segment routing or in MPLS traffic engineering, you were not dependent on a particular device. Your existing ASR XC devices were able to provide you this tunnel. On top of that, you put IPsec. These edge devices can have the data plane based on the instruction, the control plane instruction that is coming from the controllers on the top. So the controllers may be in the cloud or maybe in a remote site or maybe in Cisco cloud itself. You may have your own private cloud location or you may depend on Cisco cloud or you can have it in your one of the remote site. Now, what is the role of vBond? As the word says bonding. Bonding is connecting the edge devices to the controllers like vSmart and vManage. So the edge devices cannot immediately go and talk to vManage and vSmart. I'll come to the vSmart topic after this. But now, right now, what I want you to know is vSmart and vManage are controllers, the main controllers. vSmart and vManage are the main controllers. Now, for the edge devices to connect with the main controller, for the edge devices to connect to this vSmart and vManage, there is a need for an authentication. Because I cannot go and configure my neighbor's company's edge device. That's wrong. That's not permitted. I have to only identify my remote sites, and only on my edge devices I should push my configuration. For that there is need for a discovery process. Like NHRP, you remember we saw in DMVPN. NHRP helps to discover spokes. NHRP helps to discover spokes. Likewise, we need some mechanism to discover our own edge devices. For that, vBond plays a vital role. That's why it is called bond. vBond only identifies the edge device of your company. The edge devices may be somewhere in a geographical location. It may not be there in the same city. Now vBond checks the authenticity, the credentials of edge device. After authenticating the edge device, vBond will direct the vEdge or the edge device towards vSmart and vManage. Now with the location information of vSmart and vManage, it just goes and registers themselves with the vManage. And through the vSmart, all the control plane informations are shared. For example, you want to run OSPF on site 20. Who will push that information? vSmart. Actually, I have said a very important story now. I don't know how much you understood. If you want to reframe it, you can do that. Or if you want to ask question, you can ask me question. Or if you want me to repeat it, I can repeat it. See, we have vManage. The role of vManage is to collect the inputs from you. Based on the inputs, vManage is going to create the codings, the XML codings for the remote sites. But who is going to take those information to the remote site? It's the vSmart. So vManage has got a role to do. vSmart has got another role to do. But vSmart and vManage depends on vBond's recommendation. vSmart and vManage will talk to only those people who were approved by vBond. vBond should say, yeah, these two or this guy, this edge device is our legitimate edge device. So when vBond guarantees that this is our edge device, only then vSmart and vManage will consider the edge device and push the configurations. So what vBond will do, vBond will have a digital signature, and when an edge device want to become a part of SD WAN, our company's SD WAN, edge device will go with the certificate. vBond will verify the signature in the certificate. When vBond identifies the edge device as genuine after checking the signature in the certificate, vBond provides the location information of vManage and vSmart. Till that time, edge device will not know about the whereabout of vSmart and vManage. Only after authentication with vBond, edges knows about the location of vSmart and vManage, and they go and approach vSmart and vManage, and the fabric get extended to this new site. Some configurations are directly given by vManage to the vEdge or edge device, and most of the configurations are pushed through vSmart. I repeat, some configurations which are global to all the sites will be given by the vManage to the sites directly. But the other control plane informations are only shared via vSmart to the sites. Based on the vSmart's instruction, the data plane get built on the edge device. So it is only the information given by vSmart makes the routers on the edge device, means the edge device on the sites, to forward a packet to a particular path. Please ask me questions. No, did you really understand what I said completely? Okay, let me try. Yeah, please, that is what I want. What do you understand? True. via vSmart. Yeah, those global configurations for all, which are common for all sites, will be provided directly by vManage. But those that are precisely, see, for each site you will have different policy. So those things are only provided via vSmart. Hmm. Yeah. See, that's a language. Hmm. Hmm. Correct. Based on the inputs that we give on vManage, the necessary machine level language, the codings, gets generated and pushed to the edge device. 1 minute, please. I got a call. All the configurations are auto generated and pushed. Before pushing, you can also verify those configurations if you want. You can see this configurations, what it is going to push. But it is always through vSmart. There is one protocol called OMP, Overlay Management Protocol. I do not want to get into those things today, but I'm just giving you the overall now. What is vBond? Why we need that? What is vSmart? Why do we need? What is vManage? Why do we need? In order to configure, you need vManage. In order to distribute the control plane according to your policy to those edge devices, you need vSmart. To identify the edge devices, the genuine edge devices, and combine them to our fabric, SD WAN fabric, you need vBond. Now, coming to the edge device, you have Webtera's edge device, because the Cisco initially was not having this SD WAN. They purchased a company called Webtela. Then later they also converted one of the 1000V uh, XE operating system, Windows XE 1000V, to support SD-WAN to act as an edge device. So those edge devices are called as C edge devices. Here you see all Cisco edge devices, which means you will not you will not feel you are in a new device. This is same like what we used to have in a CLI, same CLI. Only the one thing is it can accommodate the control plane information and convert it into data plane and use those things. Now, so you may see the terminologies like C edge and V edge, both are same. V edges are Webtailas edge device. You have purchased from Cisco. C edges are Cisco's own edge device. Cisco stopped promoting V edges, so it is only C edges or WAN edge. Now we don't call C edge or V edge, we call it as W edge or WAN edge. Instead of calling it as V edge, C edge, so those confusions are no more. We simply call it as W edge or WAN edge. In our lab, we are going to use C edges. Cisco has provided the lab, and this lab is going to only have Cisco edges devices, not V edge. Mhm. If you have 256 or 128, a minimum 128 GB RAM, yes, I think you can very well do it. I'll try with my 64 GB Nook server. I have not still I tried once, but later I found that there is a need for any license. Now I also have the license file. I'll try. I'll see if it can be